This is the Denton Desk 4. Welcome to the training. This is a Denton Desk 4 sputter coater. It's fitted with a platinum target. When you have a sample that's ready to go into the system, the first thing to do will be to come over to the top here. We'll wake up the display. There's a touchscreen interface here for turning the system on and off. There are several different choices for controls. Typically we use the vacuum control and the timed sputter control. If you touch vacuum, this is where you would come in and turn the pumps on and off, and also open the gas valve for the process gas. There is no turbo pump, so do not bother touching the turbo pump button. When you get ready to open the top of the coater, it's very easy to come in, lift the top, holding the rail as well as the top itself, and moving it out of the way. You can move the glass bell jar out of place and then insert your sample into the chamber. So in this case here, we could load our sample, put it onto the pedestal. The sample has already been mounted on a holder. You can very easily come in, set the coater head down, slowly rotate the chamber top into place, make sure that it is centered, and then come over and turn on the pump. We'll take a moment for the vacuum display to register, but as soon as it does, it will start to count down. There it goes. Now basically what we're going to do is bring this down to the best possible base vacuum that you can achieve. Typically less than 10 millitorr is possible. So we'll wait a moment for that to happen. If the vacuum should ever plateau and this number is progressing very slowly, you can open the process gas valve, which will flush the chamber with argon, ultra high purity, very dry. Close that valve, and then the system will start pumping down. So if your sample has water vapor associated with it, or any type of hydrocarbons or solvents or anything like that, this can help you pump it down a little bit more quickly. There is an adjustment for the gas valve setting, but typically we've already preset this value for the pumping speed of this pump. So it should give you an optimal amount of gas flow in order to get a good sputter coating. We basically have a couple of different ways in order to control our thickness. One would be gas flow, which we've set as a constant. The other would be the power that's being supplied to the sputter head. That would be how quickly you're sputtering. And then the other option would be how much time you are going to utilize. And there are a few things to keep in mind when you do this. Typically, we've found that the best possible coatings come with a relatively slow coating. Generally, if you coat with a very high power and a very high gas flow, the material that deposits on the sample typically becomes very clumpy. And a lot of times it will look like dried mud that has started to crack. Okay? You don't want to see that type of surface because that will typically obscure the features that you're looking for. As for a thickness, I believe the coatings are typically less than 10 nanometers. But again, it's a conformal coating, and typically the beam penetrates through that coating, so you're going to see typically the things that are subsurface. Really, this coating is used to help dissipate the charge on the sample, help draw that charge away from the area that you're imaging, and bring it to ground. Okay? For sake of illustration, we're going to be okay with 42 millitorr. We'll turn on the gas, and at this point we'll leave it on. There we go. We'll leave it on. We'll wait for it to stabilize. We'll come over to the time sputter setting. First thing to note is there is no rotation on this stage, so don't bother changing that from 0. The other options that we have here is the sputter set point. That's how much power you're going to utilize out of the total power supply settings, and then how long the sputter time would be for. So right now 30% typically gives us the best or the lowest possible energy at which we would obtain a stable plasma. And then of course our sputter time is now set to 30 seconds. Typically the longer you coat, the thicker your coating will be. So to increase coating thickness, we could either increase our time or we could increase our power supply setting. If your sample is mesh-like, like an electrospun fiber or something like that, you may want to consider using a little bit longer coating times in order to penetrate a little more deeply. But typically we find about 30% and 30 seconds will typically give us a good coating. Okay? At this point we could press you can see the gas pressure has stabilized. We could come in, start our sputter coating, and then you can see how much current is currently being drawn. Okay? So that gives us an idea of how much power is being utilized. At this point, once the coating has completed, we come back to the main menu. We go to the vacuum control panel. At this point, we would turn off the gas valve, and then we would turn off the pump. And then the system would bleed back down to atmosphere. Once it's reached atmosphere, gently lift the top, and then you would remove your samples from the coating chamber.